Nvidia just pushed back the launch of its next supercomputer chip by 2 full years, and that delay is about to send shockwaves through every AI company on the planet. The chip's called Kyber, or sometimes Rubin, and it's supposed to be the successor to Blackwell, which is already the most advanced AI processor in the world. But here's where it gets complicated. Serious manufacturing problems in Taiwan have forced Nvidia to extend the timeline from 2026 all the way out to 2028. We are talking a full 2-year slip. For a company like OpenAI or Google that's burning through billions of dollars every month to train the next generation of AI models, that's essentially an eternity. It completely changes everything about their plans. Nvidia controls roughly 80% of the entire AI chip market right now. If they can't ship new silicon on schedule, the whole industry has to completely rethink its strategy. This isn't just about Nvidia being a bit late with a product launch. It's about whether we are reaching superintelligence by 2027 or looking at 2029 instead. And that raises a serious question that should worry everyone. What happens when the world's most critical technology depends entirely on one company operating in one country that keeps running into massive supply chain nightmares? So what exactly is Kyber, and why does a 2-year delay matter so much? Think of AI chips like smartphone processors. Every couple of years, a new generation arrives that's faster, more efficient, and does more simultaneously. Nvidia's been on an insane upgrade cycle. They shipped H100 chips a couple of years ago, then Blackwell last year. Kyber is the next step, and it's supposed to be a major jump. We are talking denser transistors, faster memory, better power efficiency. For a company running an AI data center, that means fewer chips needed to train bigger models, which saves enormous amounts of money and electricity. Blackwell can train cutting-edge AI systems, but Kyber was supposed to do it much faster. The performance jump between generations might be 30 to 50%. That's not incremental, that's transformative. When you're spending hundreds of millions on AI capability, 50% speed boost means better models with the same budget or equivalent models trained in half the time. For OpenAI, it's the difference between launching a new model next year versus the year after. For Meta, it's whether they can catch up to competitors. So when Kyber gets delayed by 2 years, every company is stuck using today's Blackwell chips for much longer than planned. They can't scale as fast, they can't innovate as quickly, and that gap costs real money. Now the question everyone's asking is, why is making these chips so hard that Nvidia can't even hit their own timeline? Here's the reality that most people don't understand. You cannot manufacture the world's most advanced AI chips anywhere on the planet except Taiwan. Specifically, Taiwan Semiconductor Manufacturing Company, or TSMC. TSMC runs the factories where Nvidia, AMD, Apple, Qualcomm, and basically every cutting-edge chip company on Earth manufactures their designs. Taiwan dominates the global semiconductor supply chain. So when you're trying to build Kyber at the absolute bleeding edge of what's physically possible, chips with transistors measured in single-digit nanometers, you're fighting against the laws of physics. The manufacturing process is called 3-nanometer technology or smaller. That's impossibly tiny. You're essentially etching patterns onto silicon with machines that cost billions of dollars, and every tiny mistake ruins the entire chip. Yields drop dramatically. Out of every batch you manufacture, maybe 50 or 60% actually work. The rest are garbage. TSMC has been struggling to ramp up production across the board. They're making Blackwell for Nvidia, chips for Apple, processors for AMD. Demand is outstripping their capacity massively. So when Nvidia tried to schedule Kyber production, TSMC basically said, "We can't hit that timeline. We're already drowning." And that's the story. So what does this mean on the ground for the companies actually building AI? Let's say you're Google and you're trying to build the next generation of Gemini. You've got to train a massive AI model. That requires thousands of Nvidia GPUs working together in a data center. Blackwell chips can do that today, but if you want to train a model twice as smart, twice as capable, you'd want Kyber. Now you're stuck. You can either wait 2 more years for Kyber, or you buy way more Blackwell chips right now to compensate. More chips means more power consumption, more cooling systems, more physical space, and way more money. Some companies are doing exactly that, throwing extra Blackwell chips at the problem just to bridge the gap. But that's inefficient and expensive, and it still doesn't get you the performance you wanted. OpenAI is almost certainly in this position. Meta definitely is. They all signed up for Kyber. They probably had budgets and timelines planned around having it next year. Now they have to either delay their own AI releases or overspend on Blackwell to try to bridge the gap. There's also a second effect. Right now, everyone's hoarding Blackwell chips because they know Kyber's delayed. Demand is artificially inflated. Prices stay high, so companies can't even get Blackwell at reasonable prices. It's a supply chain nightmare that cascades through the entire industry. So here's the natural question: can competitors like AMD or Intel step in and fill the gap? The short answer is no, not really. AMD makes the EPYC processor, which is competitive with Nvidia in some narrow situations, but it doesn't have anywhere near the software ecosystem that Nvidia commands. Most AI frameworks, PyTorch, TensorFlow, all the tools engineers use, are optimized for Nvidia chips first. AMD support comes second, if at all. Building an AI model on AMD chips is technically possible, but it's harder, slower, and way less reliable. Intel has been trying for years to build competitive AI processors. They haven't succeeded. Their latest offerings are years behind Nvidia's capabilities, so Nvidia has this almost unbreakable monopoly. When Kyber delays, there's no realistic plan B. Companies can't just switch to AMD and get the same performance. They are locked in. This is actually part of why the delay is so damaging. Nvidia owns 80% of the market. Their competitors are nowhere close. If Nvidia had real competition, companies could pivot quickly. AMD could ramp up production, offer competitive pricing, and companies could diversify their suppliers. But AMD can't ramp. They don't have the market share or the capital or the software maturity. So the entire industry has to wait. And that waiting period is worth billions of dollars to the companies trying to build the next generation of AI systems. Here's what this delay means for the future of AI. It slows down innovation across the board. Model releases get pushed back. Capabilities that were supposed to arrive in 2026 might not show up until 2027 or 2028 instead. That sounds like a small change, but in AI time, that's massive. Every few months, the models get smarter, faster, more capable. A 2-year delay in hardware is a 2-year delay in what the models can achieve. There's also a massive financial impact that people don't talk about. When you can't scale efficiently, you can't reach the level of performance you're aiming for without spending way more money than planned. Companies will burn through billions of extra dollars over the next 2 years just trying to compensate for the lack of Kyber. That money could have gone to research, to hiring engineers, to building new product lines. Instead, it's just keeping the lights on at the data center. And here's the deeper problem. It makes the entire AI industry even more dependent on Taiwan. Right now, Taiwan's TSMC is the only place on the planet capable of making these chips at this scale. China wants to build chips, but can't yet. The United States wants to build chips domestically, but doesn't have the capacity yet. So Taiwan has become a single point of failure for the entire global AI industry. If there's ever a disruption, political tension, natural disaster, anything unexpected, the whole world loses access to cutting-edge AI chips instantly. So what's the play for companies stuck waiting for Kyber? They've got a few options, and most of them are far from ideal. Option 1, wait. Just hold off on major model training until 2028 and hope Kyber shows up on time. But that means competitors who find workarounds get ahead of you in the market. Option 2, buy way more Blackwell chips right now and brute force your way through the timeline. This technically works, but it's expensive and inefficient. You're spending billions of dollars on hardware you didn't really want. Option 3, optimize your software like crazy. Make your models run faster on Blackwell, squeeze out every % of performance the hardware can give you. This requires hiring tons of engineering talent, but it actually works pretty well. Meta's been doing this aggressively. They've hired huge teams of engineers specifically to optimize their AI models for Blackwell. You can get pretty close to the performance jump you'd have gotten from Kyber, but you have to earn it through software engineering effort. Option 4, explore custom chips. AWS has some custom processors. Google has their own TPUs, but these are niche plays with limited software support. Most companies are doing some combination of options 2 and 3, buying more Blackwell chips, hiring optimization teams, and hoping that gets them through until Kyber finally arrives in 2028. Here's what this Kyber delay means for you and the future of AI. First, it proves that even when one company dominates an entire industry, supply chain bottlenecks can grind everything to a halt. Nvidia's in an unbeatable market position, but they are still vulnerable to manufacturing constraints thousands of miles away in Taiwan. Second, it means the timeline for AI capabilities is going to change. Models that were supposed to launch in 2026 are coming in 2027 or 2028 instead. If you've been waiting for a specific breakthrough in AI, better reasoning, better code generation, better anything, it's going to take longer than expected. Third, it puts real pressure on governments and companies to build alternative chip manufacturing outside of Taiwan. The United States has been investing heavily in Intel and other domestic chip makers. Japan and South Korea are investing too, but none of these efforts will be ready for years. We are stuck with Taiwan for the foreseeable future. The big takeaway: the AI industry is way more fragile than most people realize. It depends on one company, one country, one manufacturing process. When anything goes wrong, innovation stops. Keep watching what happens with Kyber over the next few months. If the timeline slips even further, that's a massive signal that the supply chain crisis is worse than anyone's admitting. Follow for daily AI news so you stay ahead of these developments as they unfold.